Alrighty, here's our 8.1 notes, you guys. We're going to review some exponent rules that we've hopefully again seen in the past, but we're going to review product of powers when we're multiplying two expressions that have the same base, and quotient of powers when we're dividing. So product of powers property, we got it listed right here. The product of two powers with the same base equals the base. So that base, it doesn't change, raised to the sum of the exponent. So what we might define here is when we have something raised to an exponent, right? This is the exponent, and this is the base. So when we talk about base, we're talking about the big number being raised to the power. And then whenever we're multiplying two powers together, we're going to add those exponents. So for example, in this little box here, right, 6 to the 7th times 6 to the 4th, the 6 stays the same, and then we add the exponent 7 plus 4, so we get 6 to the 11th. So for these examples, we need to simplify. We need to simplify fully. Okay, that means we need to have any fractions reduced, and we cannot have any negative exponents, which we're going to review some more of. I don't think we'll run into it all in these examples, but we do want to keep that in mind. Fully simplified, no negative exponents. So as we're looking at this first example, we have 4 times x to the 5th times negative 3 times x to the 2nd. So kind of like when we combine like terms, we're going to multiply our coefficients together, the 4 and the negative 3, and we get negative 12. And then we're going to multiply x to the 5th times x squared, which, as we reviewed up above, to do that, our shortcut is we're going to add those exponents together. So we end up with 12x, or negative 12 times x to the 7th. We have no negative exponent. We have a negative coefficient. That's fine. We have no negative exponent, and we have no fraction. We need to simplify. And the next one, we've got m squared times n times m times n to the 4th. So all of these are being multiplied together, right? If we don't have any operation listed between our letters, our variables, if we don't have any operation in between our parentheses, then we have multiplication there. Okay, so m squared times m squared times m. M without an exponent is m to the 1st power, n times n to the 4th. So we're going to multiply our two n terms together, multiply our two m terms. We end up with m to the 3rd power when we add these exponents together, times n to the 5th power. Because again, that n would have a 1 on it. And then again, as long as we have no negative exponents and no fractions to reduce, we are simplified. So product of powers, we add our powers together. Okay, so same here, same type of problem. We're going to go negative 3 times negative 2, that is positive 6. X times x to the 3rd is x to the 1st times x to the 3rd, that gives us x to the 4th. And then y to the 3rd times y to the 1st gives us y to the 4th. No negative exponents, no fractions to reduce. In this one, we just have, we do have a different operation in here. So what we're going to do first is we're going to do order of operations. Multiplication comes before addition, right? PEMDAS. Okay, we do want to keep that in mind as we're working algebraically. Okay, we're going to go negative 2 times times 4. That gives us negative 8. Y times y cubed will give us y to the 4th here. That's our first little grouping. And then we have plus 3 times negative 6 is negative 18. And then y squared times y squared would be y to the 4th. We're going to add those exponents together. So now we have negative 8 y to the 4th plus negative 18 y to the 4th. Since they have exactly matching variables, we can combine like terms. So this is like if we had 2x plus 3x, we would add our coefficients, right? Our variable does not change. We simply add, combine our coefficients. Now if we have 2x and x squared, we cannot add those together. they don't combine because the variables don't match. So your variables have to match exactly in order for you to combine like terms. So we have negative 8 y to the fourth plus negative 18 y to the fourth. Our y to the fourth is going to stay the same. Our variable's not going to change. And the negative 8 and the negative 18, when we combine them, is going to give us negative 26. And that is something you can check with a calculator. Right, but if we have negative 8 and then we add negative 18, adding a negative is the same as subtracting. So we're going to move 18 to the left down our number line. We're going to subtract 18 from 8. Okay, so that's reviewing product of powers. So when we're multiplying two powered expressions together, we're going to add our exponents. Quotient of powers is when we are dividing two powered expressions. Our shortcut is to subtract the exponents. So on our first one, so we can see here, right, example here is that 6 to the 7th over 6 to the 4th gives us 6 to the 7 minus 4, which simplifies to 6 to the 3rd. So we're going to look at this first problem here. We need to simplify our bottom piece here. So the 2 exponent outside, the e is going to get squared and the d is going to get squared. And we're going to review that a little bit more too. But when you have a power on the outside of your product, both parts or all parts of the product will get raised to that power. And then on the top we have d to the 4th e cubed. So now here we're going to look at our d's together and our e's together. D to the 4th over d squared is going to be d to the 4 minus 2. And then e to the 3rd over e squared is going to be e to the 3 minus 2. So whatever number is on top, you subtract the number that's on the bottom for those exponents. Okay, not if we have a number on top of a number, we don't subtract them, right? That's division. But the shortcut for our exponents is that we can subtract it. So if we simplify this, we end up with d squared e to the 1st, or just e. So that's our simplified expression there. X to the 4th over x cubed would be x to the 4 minus 3, or just x. Okay, we can also look at it. X to the 4th is x times itself 4 times, right? And x to the 3rd is x times itself 3 times. Well, we know that if we have something on the top and bottom of our fraction, then they reduce, they cancel each other out. So if we wrote out our x's, expanded that expression, and then canceled out our common terms, then we would end up canceling out 3 of those x's and we'd be left with just 1 x. That's another way of thinking about that problem. Okay, and then on this one we have numbers instead of variables being raised to a power, but that's fine. We can still do the same kind of trick here. Okay, we've got 3 to the 5 minus 4, 2 to the 4 minus 2, and then we have 4 to the 3 minus 6. So what we can recognize is that right here with these 4's, we have more 4's on the bottom of our fraction. So when we're done with this problem, there should still be 4's. Or when we're done simplifying this, there should still be 4's on the bottom of our fraction. So 3 to the 5 minus 4 is going to give us 3 to the 1st power, or just 3. 2 to the 4 minus 2 is going to give us 2 squared. And then 4 to the 3 minus 6 is going to give us 4 to the negative 3rd power. So what we'll review tomorrow in class, well, you'll be watching this video after we review it, okay, is when we have negative exponents, they have to go to the bottom of the fraction in order for the exponent to become positive. And again, hopefully that's not brand new information. Maybe that's ringing a bell. Okay, but whenever we have a negative exponent, it's got to switch wherever it is, right? And we talked about at the beginning, we had more 4's on the bottom of our fraction. So when we simplify, we should still have 4's on the bottom of our fraction. So when we move that 4 to the 3rd power, the 3 and the 2 squared stay on top. They don't have negative exponents, so they don't need to go anywhere. And then we end up with 4 to the 3rd power on the bottom. When we move it, exponent becomes positive. Okay, now with this particular problem, if these were variables, we'd be done. But since these are actually numbers, we can keep we can keep going. We can simplify this even further, right? Because we can do 2 squared, that's 4, and we can do 4 cubed, 64. And then we can go to simplify it even further. We're going to have 12 over 64. And as we mentioned before, in order to be fully simplified, we need to simplify any fractions, reduce any fractions. So I know that 4 goes into both of these. So I'm going to divide both of these by 4. And I know that 4 goes into both of them because I had a 4 right here and I had a 4 right here. Okay, but you could also just play around with it on a calculator, see what goes into it, or you could start with 2. You know that 2 goes into both of them because they're even. Okay, 12 divided by 4 is 3. 16 divided by 4, 64 divided by 4 is 16. So we end up with 3 over 16, which cannot reduce any further. So that is our fully simplified form. Okay, and that is it for reviewing product and quotient of powers. So quotient shortcut is to subtract our exponents, and power shortcut is to add our exponents. Let me know if you have any questions.